Okay? So, no on that. Number 17. So anytime you get a fraction, you got to make sure that your x is not falling in that range or in your interval. That one was, because the range between -8 and +8, we got 0, which is right smack in the middle. Not good. Next one. Now this one's kind of an ugly spot. We got f of x is equal to x squared minus 2x minus 3 over x plus 2. We may have an issue here, so let's see how this works. So this is going to be interval from -1 on the left side to +3 on the right side. Now you see a denominator, and woo, bells and whistles going off. Cats and dogs living together. Not good. However, we know when we look at this that this cannot equal 0, so that means x cannot equal -2. Well, if you look right here, that does not fall into that interval. So while that is true, since we're only looking at the interval from -1 to 3, this is going to be fine. Okay, so it's continuous through that interval. It's not continuous otherwise. But now the next question is it differentiable? And for that we have to find out what f of 0 is. Although not say it's 0, well, we have to find the slope and see that if we have a 0 or not. So let's do that. So f prime of x, and this is where it gets a bit nasty. This is going to be x plus 2, make sure you get this right, yeah. X plus 2 times this whole thing as a derivative. So the derivative of x squared is 2x. Derivative of -2x is -2. And then -3 drops out. And then subtract, because we're using the quotient rule here. So now, we're going to take this, x squared minus 2x minus 3, times the derivative of x plus 2, which is just plain 1, all over. Now we square that denominator, x plus 2 times squared. Alright, so I'll save you the time going through multiplying and adding and subtracting and all that nonsense. But we end up with x squared plus 4x minus 1 over x plus 2 squared. Well, again, x can't be equal to -2, but that's not in their interval here, so we're not going to even look at the denominator for this. We're just going to focus on this part right here to find the value of x that's going to give us 0 as a numerator. So x squared plus 4x minus 1 equals 0. And we're going to assume that all the other numbers within this is going to be somewhere doable. It's not going to give us a -2 for an answer. That doesn't fit. So anything in the 0 in the numerator is going to automatically make the whole fraction 0. So that's why we're focusing just on the numerator. So, can't factor this out either. So we quad form this thing. And we get x, which is going to be c, is equal to 0.236 and -4.24. Well, here's another issue. The c, the 2.236, falls in that interval, but the -4.24 does not. So, this is not a value of c. This is the only value of c that we can get. Alright? Last one I want to do for you, I want to do a trigonometric one. Show you how easy this is. Number 19. F of x equals sine of x. And The interval here is 0 and 2 pi. So the first thing we got, well, first of all, we know that this is a sine curve, like that, all the way across. So we know it's continuous. We have to find out what f sub 0 is. That equals the sine of 0, which is 0. And again, if you're going to do this, make sure you got it in the radian mode. So f of 2 pi equals the sine of 2 pi, which is, again, 0. So these two are equal to each other. So that's a doable thing. We have no denominator here, so that's nice. So now we are going to take the slope of this and find our value of c from that. So f sub c, I'll go ahead and see it now. And the f prime of c, so that means then that we have to take the derivation of sine of x, or sine of c in this case, and so that's going to be cosine of c. And that's going to be equal to 0. And you can use your calculator for this if you want. You get the inverse cosine of 0, or you can hit, you can know your facts about cosine at points at which there's 0. And that happens at 90 degrees and 270 degrees, or in terms of radians, pi over 2 and 3 pi over 2, which is about 0.7, about 2.1 or 2.2. But regardless, those are your values for C. And that's how you use Rolle's theorem. So your assignment on page 176, 12 through 20E. Have fun.